Okay, in the previous step we learned how we can make a system for look at an object at runtime by C# Unity. Okay, now in this step we want to learn how we can change a variable consistently, not just by jump. For example, we have here a public game object, cube. Okay, this is my cube, and I will say this is public vector 3. This is the position or rotation or any variable which can be in x, y, z format. So I say target position. Okay, and I will say let me change it to transform. It is easier. Cube dot position equal target position. Right? Let's come over here. This is my cube. Okay, let's add main to the main camera. Okay, and this is my cube. Okay, the position of my cube is 0, 0, 0, right? I want to jump to 9, 0, 0, for example. Okay, so I will say the target position will be 9, 0, 0. Correct. Now I play the scene. Look at this. It jumped to this position 9, 0, 0. Okay, but I want to do something better. For example, the target position is 9, 0, 0, right? But I want to see something like this, a smooth movement to reaching the destination. Okay, for this reason it's better to use, instead of this structure for this code, for this action, let's use vector3 dot lerp. Okay, the lerp says, okay, please give me current location. I'll say current cube position, and give me the second vector3 variable, which will be target position. Okay, and also please tell me how much time you want to spend to reaching this point, or in fact give me the period of time for this action. You want to do it, for example, during 1 second or during 1 hour. Okay, so for example I say time dot delta time times say okay, public float velocity. Okay, for example, I did here, right? And the velocity can be 3. Okay, no, it's better to put, for example, 1 second, because it is velocity, so it's better to be slower to better understand for this functionality. Now it is 1. Okay, now play the scene. Look at this. It reached the point. It's almost reaching the point. It never arrived to destination until here. Look at this. Never arrived. So, but we can imagine it has been right. So it is here. If we make it, for example, 3 seconds, look at this. It will be more faster. That's the kind of jump. Okay, so it's better to keep it 1. It is a good action for changing the the target destination smoothly, not by jump. For example, look at this. is 2 or 5. Look at this. And 0, 0, 0. It is beautiful. We can use this Lerp for other use cases. For example, let's ignore public cube and also a target destination. Let's add public, for example, light, test light. Okay? We want to change the intensity of light smoothly. Okay? For example, I will say target, target test light dot, for example, intensity equals math f dot lerp. Okay, and here, for example, the intensity will be 0.5. Let's remove cube and add light. Oh no, sorry, it's direction light. Let's add a point light, okay? And put an object to better understanding what is going on with our light, right? Yeah, for example, if it is our light, it's probably something like this. Yes, we can see the intensity here. The intensity by default is 1. And if we do something like this, we can change the intensity in runtime. Okay, let's come back here. The default one is number 1, and the target number can be 5. During our time delta time times velocity. And now look at this. If we click on point light, oh, I need to attach point light to here, sorry. Okay, I click on point light. Now take a look at intensity here. Look at this. It will be like this.